Okay, this week we're going to look at distinguishing or identifying which one we have, a linear, quadratic, or an exponential. This first section, we are just looking at what type of equation we have. So the function is written as an equation. So we should remember some information. If it just has an x, then it is linear. If it has an x squared, then it is quadratic. And if it has an x in the exponent, then it is exponential. So I'm going to look at a couple of these with you. Let's start with A. It just has an x, and that tells me that I have a linear function. Let's skip down to E. If I look at it, the x, or the variable, is located in the exponent, and that would make it exponential. Okay? And then let's look at one more. If I have a square or a 2 as my biggest exponent, that is going to be quadratic. And if I look through here, it looks like I have one that has 2 as my exponent, and that would be f. So that is looking at linear, quadratic, and exponential. So you're going to need to finish B, C, and D. Now we're going to look at how to do that with a graph. I think that we were all pretty good with identifying these. So let's just look at a couple of these. I want to first look for a linear one. I know linear means line, so I'm going to say that D is definitely linear because it does not curve at all. Let's go ahead and look for an exponential function. That means that it is approaching an asymptote. It won't go on forever, or it won't keep going towards infinity as far as the y value. So let's see. C looks like it's exponential. And I know that a quadratic function is going to have a parabola, which is that curved U shape. It does not look like I have that here, so let's look at the second row. Ooh. I have two that have curves. E has a curve, and G also has a curve, but there's a difference of E continues going up forever, and G is something that I do not think I've seen in Algebra 1 this year. In E, I have what is called a parabolic function, so that would be my quadratic function. In G, if you noticed, it says or neither. Since it says or neither, I know that there is also that option that it is not going to be any of them. And this is not something I've seen before, so this would qualify as neither. And I'm just going to leave an N for now. So that is looking at graphs and deciding. So you're going to finish the rest of those. And then we're going to come down and look at identifying functions from a table. Now, I am going to go ahead and fix these. You may notice that these are not on top of the boxes. That is where they're supposed to be. So I'm going to go ahead and mark those out and put them where they are supposed to be. The first one should be linear. And then we're going to have our quadratic. And then finally, we've got an exponential. And these are our rules for looking at a table and determining if it is linear, quadratic, or exponential. So let's look at the two easy ones first. We're going to look at linear and exponential. These two you've probably noticed or made these up on your own. A linear function, as the x value increases by the same amount. So if you look over here, you're going to notice that all of these are the same. These are all going up by 1 in the quadratic, so that's plus 1 each time, so those are all the same. And these are going up by 1 each time. So if I have the same amount changing on my x's, these rules are going to change or explain to me what it is changing by on the y's. So in a linear function, I am adding or subtracting the same amount each time going up. So if it says with a linear function, they have constant first differences. So it adds the same number over and over. So from 4 to 3, I went down 1. From 3 to 2, I went down 1. From 2 to 1, I went down 1. It says I'm just going to skip to exponential because that's another one we've seen before. It says it has a constant ratio, not a constant rate, which means it multiplies by the same number over and over again. And we've talked before about I always multiply by the same amount when I'm doing exponential. So it says that it's 3, so that's what I'm multiplying by. Times 3, 6 times 3 is 18, 18 times 3 is 54, and then 54 times 3 would be 162. The quadratic one is not something that we've really noticed. You see this on a graph. You see this on a graph pretty easily. The quadratic one is going to be constant second differences. Already have green. So yellow. So when I go through here, the first time I go through, I went down 1, 3 to 2 is down 1, 2 to 3 is up 1, 3 to 6 is up 3, 6 to 11 is up 5. These are not constant. There's nothing going on that makes sense here. So it's not linear. It wasn't the same amount. But what I did is I now look at the second one. How far is -1 to +2? From -1 to +2, I go up 2. From 2 to 3, I go up 2. From 3 to 5, I go up 2. So when I look at this, I had +2 as my second difference, which tells me that is a quadratic function. So these are the basic notes. Let's look at some of these and actually do them together. So we are going to determine whether we've got linear, quadratic, or exponential. And let's start with C. First thing I'm going to do is I'm going to check this side and see that they are going up by the same amount. So from -1 to 1, I go up 2. From 1 to 3, I go up 2. From 3 to 5, I go up 2. Cool, that's what I needed. On the other side, I'm going to check and see how much they're growing by. So from -9 to 9, I'm going to go up 18. From 9 to 27, I go up 18 again. From 27 to 45, I go up 18 again. It says it's going at a constant rate. I added the same amount every time. That would be a linear function. Let's look at another one. Let's go ahead and look at let's go ahead and look at E. So in E, let's make sure I'm going up by the same amount here. That's 1. I go up another 1. I go up another 1. And I'm going to look at it, try and decide, do I want to add or subtract? So let's check it out. If I go from 16 to 8, that would be -8. If I go from 8 to 4, it'd be -4. I already know it's not linear because these two are not the same. Then I go down 2. Said 2, wrote 4. Okay, So this is definitely not linear. We can cross that out. We can check for quadratic. This would go down 4, and this would go down 2. So that is not quadratic because the second difference was not the same. So I'm going to erase all this because we know it's not linear and quadratic. And I'm going to go back and I'm going to look at it the way that we've always looked at it before. What is happening here? This is one we should be able to look at and say 16 and 8. Well, 8 is half of 16. So I divided by 2. 8 divided by 2 is also 4. And 4 divided by 2 is 2. So this would be my exponential function because I'm multiplying or dividing by the same number over and over again. Now the rule said that I had to multiply, but I came and I recognized I was dividing. Remember that dividing by 2 is the same as multiplying by 1/2, right? So this would be exponential. Let's go ahead and look at D. So let's check and make sure once again. Looks like I'm going up by 1 each time. Always good to check and make sure that they're not trying to trick you. You know how state tests are when they trick you with stuff like that. And then we're going to check and see what's happening on the other side. I go down 3. And then I go down 1. Then I go up 1. And then I'm going to go up 3. Definitely not linear because these are not the same. Let's try again and see what our second set gives us. From -3 to -1, I go up 2. From -1 to 1, I go up 2. From 1 to 3, I go up 2. Those are the same, which tells me it's quadratic. So you're going to need to go through and finish A, B, and F. On this next page, we are going to have to identify if it's linear, quadratic, or exponential, and then write the equation. You guys have gotten pretty good with linear equations and with exponential equations of plugging in. I'm going to make the first example a quadratic one. I went ahead and wrote that this was quadratic because we can clearly see that it's a parabolic function. And I'm going to go ahead and label that the vertex was right here at 1, 9. Now I'm going to come back up here and use the vertex formula that they provided me with. And we are going to write this equation. So we remembered that A is going to either be positive or negative, depending on whether it opens up or down. So this one opens down. So it's going to be a -1. Then we've got x minus h squared plus k. Remember, h and k is my vertex. So we've got the vertex is 1, 9. So we're going to say x minus h, which is 1, plus k, which is 9. And that's all that we have to do to get that quadratic function, which was the hardest part to figure out. Okay. When you do the tables, you're always going to want to look for the x-intercept. Remember, that's where x is equal to 0. That's going to help you write whichever type of equation it is. If you look up here, they have very clear explanations of how to get your slope, how to get your y-intercept, how to get your y-intercept, how to get your constant ratio. If you look at this, you just plug them straight in to what it says, and it's going to be a pretty easy way to write your functions.